So what's up guys? Sa video ito ay tatalakayin natin kung ano nga ba ang Boyle's Law, Gay-Lussac Law, and Charles Law. What is Boyle's Law? Boyle's Law is one of the law in physics that concern the behavior of gases. When a gas is under pressure, it takes up less space. The higher the pressure, the smaller the volume. Boyle's law tells us about the relationship between the volume of a gas and its pressure at a constant temperature. The law states that pressure is inversely proportional to the volume. A container holds 500 ml and 742 torr. What will be the volume if the pressure is increased to 795 torr? Given V1 is equals to 500 ml, P1 is equals to 742 torr, P2 is equals to 795 torr. Solution: P1 times V1 is equals to P2 times V2. Formula: P2 is equals to P1 times V1 divided by P2. 742 torr times 500 ml divided by 795 torr is equals to 371,000 divided by 795. V2 is equals to 467 ml. As the pressure increases, the volume is decreases. Charles Law, the temperature-volume relationship. At constant pressure, the volume of a fixed amount of gas is directly proportional to its absolute temperature. V1 divided by T1 is equals to V2 divided by T2. If three of the variables are known, the fourth can be calculated. A 600 ml sample of nitrogen is heated from 27 degrees Celsius to 77 degrees Celsius at constant pressure. What is the final volume? Given V1 is equals to 600 ml, T1 is equals to 27 degrees Celsius plus 273.15 K is equals to 300.15 K. T2 is equals to 77 degrees Celsius plus 273.15 K is equals to 350.15 K. Solution: V1 times T2 equals V2 times T1. Formula: V2 is equals to V1 times T2 divided by T1. 600 ml times 350.15 K divided by 300.15 K is equals to 210,090 divided by 300.15. V2 is equals to 699.95 ml. As the temperature increases, the volume is increases. Gay-Lussac law. The relationship among pressure and temperature at constant volume can be mathematically represented by an equation known as Gay-Lussac law. P1 divided by T1 equals P2 divided by T2, where P1 is the initial pressure and P2 is the new pressure. T1 is the initial temperature and T2 is the new temperature. V1 and V2 are the same, constant volume. The pressure of a gas in a tank is 3.20 atm at a 22 degrees Celsius. If the temperature rises to 60.0 degree, what will be the pressure in the tank? Given P1 is equals to 3.20 atm, T1 is equals to 22 degrees Celsius plus 273 K is equals to 295 Kelvin. T2 is equals to 60.0 degrees Celsius plus 273 K is equals to 333 Kelvin. Solution: P1 times T2 equals P2 times T1. Formula: P2 is equals to P1 times T2 divided by T1. 3.20 atm times 333 Kelvin divided by 295 Kelvin is equals to 1065.6 divided by 295 K. P2 is equals to 3.61 atm. As the temperature increases, the pressure is increases.